Hello everyone, my name is Ajit. I am pursuing Masters in Data Analytics at Technological University of Shannon, Athlone. In this video, I am presenting one of the comprehensive system function in SQL, that is in advanced SQL, to be more precise in analytical queries. So yeah, we are talking about the regression analysis using SQL. Before we dive deep into the SQL query, so let's try to understand what is regression analysis. What is a simple linear regression? So to understand this, let's start with the term called correlation. Correlation measures the degree of linear association that exists between the two variables. Let's say x and y. As x increases, y also increases. As x decreases, y decreases, or vice versa. It means there exists a correlation between two variables. And correlation coefficient is used as a measure of how variables are related. Now we can define simple linear regression as a mathematical equation that describes the relationship between the two variables. So if we define the regression model as a mathematical equation, then what is the mathematical equation? What is the formula? What is the max behind that regression? Yes, and that is defined as y is equal to a plus bx, where y is the variable that is being predicted or called as dependent variable. Why it is dependent variable? Because it can be manipulated, and x is the variable that is used to predict y and is an independent variable and it cannot be manipulated. A is the y-intercept, b is the slope, and c is the random error. Considering random error as very negligible, we can say y is equal to a plus bx. So just keep in mind we will be using this formula in our SQL query. So for the demo purpose, I have created a database, and the ERD of the database is the one you are seeing in the screen. To the left of the diagram, you can see there are two entities, manufacturer and vehicle. And from the ERD, we can directly predict or depict that manufacturer may produce one or more vehicle, but the vehicle is assembled by only one manufacturer. And into the right of the screen, you can see other diagram that it depicts two tables, manufacturer and vehicle, and its attributes. Manufacturer has an attribute called manufacturer ID, name, city, and so on, and vehicle has attributes such as vehicle ID, make, model, category, and so on. Manufacturer ID is the primary key for manufacturer, and vehicle ID is the primary key for the vehicle. It also has a foreign key called manufacturer ID, referencing back to the manufacturer table. So this is just a brief overview of the database that I have created. Now what I'm interested is to predict the selling price of the vehicle here based on the build cost. So now let's see how it can be done. So basically, as I told, to find or predict any value, we should compute first regression slope, regression intercept, and then coefficient of the correlation. Coefficient of correlation is really necessary because we'll be going forward to the regression only if there is a strong correlation between the two variables. If there is no correlation exists between the two variables, then of course we cannot go to the regression analysis. The regression equation is applicable only if there exists a strong correlation or some kind of correlation should exist between the variables. So now let's go to the query part now. So I already built a query here. You guys are able to see my screen. In the screen, you guys are able to see the code part over here. This is a perfect example for the inline query. Inline views, sorry. So here I have a subquery, and this subquery, the table is named as with the alias called equation, and there is one more subquery here which is set as SD, sample data. I want to what I meant is, so here in this subquery, I'm finding regression slope between the two variables selling price and build cost using the analytical function called regression slope, and it is nothing but the value b in our regression equation. Similarly, I want to find the intercept between these two variables using the analytical function called regression intercept, and this is nothing but the value a in our regression equation. Similarly, I'm finding the minimum and maximum value of x. X is nothing but build cost here, and then finding the correlation between these two variables. Of course, this is needed. Let's see what is the output we get if we run this chunk of query. Let me run this. You can see I got the value of b, value of a, and then the minimum and maximum cost and the correlation. This correlation is approximately equal to 1 here. It means there exists a strong positive correlation between these two variables. What is strong positive? Strong means it is a high influence, and positive is whenever the build cost increases, selling price also increases. That is called a strong positive correlation between these two variables. So now we have found the value of a, b, and we need value of x. For what value of x? We are predicting the value of y. So here, to form a x, I have created one more subquery using union all and dual function. So I'm just appending all these values in one table. For example, 8630 euros, 1600 euros, 35,000 euros and 80,000 euros of build cost is considered as a sample data. In my case, I'm creating this data. So let me run this subquery here, and you can see I'm generating a table with these 4 sample data of x, which is nothing but build cost, and I want to predict the selling price for these values of x. Okay, and you can see these values are within the range of minimum and maximum cost, but 80,000 is not in the range of minimum and maximum cost. In this case, the prediction value may not be accurate, and this is a perfect example for the extrapolation. Extrapolation is nothing but predicting the value of y for the value of x, which is not in the sample data, which is outside the range of the sample data. So in this case, I will come back to this, why I explained what is the interpolation and what is extrapolation. Now we went to the subqueries. Now let's go to the outer query, that is the main query. Now we got the value of a and b. I will create one more regression equation, that is a plus bx, a plus b times x. X is nothing but the sample build cost from this table SD. So a plus bx, I created an equation here, and I just rounded off it for 2 digits using a round function. And then I added one more case statement here, just to say if the value of x, sample x, lies between the minimum cost and maximum cost, lies between the value of x, sample x, then it is called as a sample build cost is within the range of data considered. It is an example of interpolation, or else I'm just printing that sample build cost is outside the range of data considered, saying that it is an example for the extrapolation. So this is how the simple query is. Now let me run this complete query, and you can see I'm predicting the selling price for the value of sample build cost. And it also gives an analytics based on the case statement, whether the predicted value is for the sample range of x is within the sample data or outside the range. So let's take here, we have predicted 10,815 euros for the sample build cost of 8630 euros, and it is within the range. And similarly, 99,590 euros is the predicted selling price for the sample build cost of 80,000. But in this case, the build cost is outside the range of the data considered. It may not be very accurate. So this is what I wanted to show you today in this video. So there are many such interesting queries in analytical functions of SQL. So I will come up with the next video soon. Thank you very much. Have a nice day.